Hello grade 10 students. Welcome to another virtual class. I am Miss Madhu Vadke. Today we will start with a new chapter, that is chapter number 14, Statistics. So what is statistics? Statistics is a branch of mathematics that deals with collection of data, its representation and then interpretation. We have been studying statistics from lower classes. Let's recall what we have studied in statistics last year. In grade 9, we studied how to classify a given raw data into ungrouped and grouped frequency distributions. Then we also learned how to represent this data pictorially in the form of various graphs such as bar graph, histogram and frequency polygons. And we also studied how to represent each data using just one number. This number is called as measure of central tendency, which are mean, median and mode. In this chapter, we will extend the study of these three measures of central tendency from ungrouped data to grouped data. So in this chapter, we are going to learn how to find mean, median and mode for grouped frequency distribution. In today's video lesson, we will focus on learning how to find mean of a grouped data using two methods, direct method and assumed mean method. There is one more method mentioned in the chapter by which you can find mean, that is called as step deviation method, but this year it is deleted from the portion. So you have to learn only two methods, direct method and assumed mean method. Also, the last section of this chapter, that is finding median by graphical method, which are called as ogives, is also deleted from the portion this year. So exercise 14.4 is also deleted. Let's start by recalling the formula to find mean of an ungrouped data. We have studied that mean, which is also called as average, is given by the sum of values of observations divided by total number of observations. Observation stands for the numbers given in the data. So if x1, x2, x3 and so on, xn are the observations, then the mean, which we will denote by x bar, is given by x1 plus x2 plus x3 so on plus xn divided by n. There are n number of observations in this data. So this is an ungrouped data. Now if observations are repeating themselves, then we represent the repetitions of each observation using frequency. So frequency stands for number of times an observation repeats. So if we know how many times each observation is repeating, then the same formula can be written in a different way. That is, if x1, x2, x3, xn are the observations and f1, f2, fi, fn are the respective frequencies, then the mean will be given by f1 x1 plus f2 x2 and so on, plus Fn xn whole divided by F1 plus F2 plus F3 plus Fn. Addition of these terms can be represented using a symbol called as summation. This is a Greek letter sigma, which is used for summation. Fi xi whole divided by summation Fi, where I is from 1 to n. So this is the formula that we have studied in grade 9, which is meant for ungrouped data. Here is an example for ungrouped data. We have marks obtained out of 100 in a test, and the number of students getting those marks are indicated in this row. Now the same table is made over here. Marks obtained is the data, which is represented as xi, and the number of students getting these marks represents the frequency, which is denoted using Fi. So in order to calculate mean of this data, we have to find the product of xi and fi for each data. After you have found the product fi xi, we have to add all these to find summation fi xi, and also find the sum of frequencies. So now using the formula, x bar, that is mean, is equal to summation fi xi divided by summation fi. Mean will be equal to 1779 divided by 30, which is equal to 59.3. Here we have only 13 observations. So it's easy to use this method. But if we have a data that has 500 observations or 1000 or even more in lakhs, then finding mean by this method will become very difficult. Hence, we need to convert the given ungrouped data into grouped data. Now in this chapter, you don't have to convert an ungrouped data into grouped data. This you have already learned in lower classes. So we will quickly understand what do we mean by grouped data. So what we will do is we will divide this data of marks obtained into groups, which are called as class intervals. This is the table that represents the same data, but now this is a grouped data. So we are representing marks obtained in the form of class intervals 10 to 25, 25 to 40, 40 to 55, 55 to 70, and so on. By doing this, we have reduced the data to just 6 class intervals. So 10 to 25 is called a class interval, where this number is the lower limit and this number will be the upper limit. Also notice that the lower limit of the second class interval is the upper limit of the first class interval. Likewise, the lower class limit of third class interval is same as the upper class limit of the second class interval. So these class intervals are called continuous class intervals. So this particular example is an example of continuous class intervals. However, if the same class intervals were written in this way, 10 to 24, 25 to 39, 40 to 54, 55 to 69, then these class intervals will be called as non-continuous class intervals. The number of students that get marks which fall in this class interval will be the frequency. So this column represents the frequency Fi. In order to use the formula to find out the mean, we need to know what is xi. So here, since we have grouped the data into class interval, we will have to find a number that represents each class interval, and that number will be called as class mark. Since class mark represents this class interval, it should be the middle value of this group. So class mark can be calculated by adding the lower limit and the upper limit and then dividing it by 2. So for the first class interval, the class mark will be 10 plus 25 divided by 2, which will be 17.5. Similarly, for the second class interval, 25 plus 40 divided by 2 will give us 32.5. And so on, we can find class mark for each class interval. We represent class mark with xi. So now the same table can be written in this way. Here are the class intervals. Then we have to write down frequency for each class interval. The next column shows class marks. Now we have both these numbers xi and fi, so we can find the product xi into fi in the fourth column. On adding these products, we will get summation fi xi. And now we can use the formula to find the mean, that is x bar is equal to summation fi xi divided by summation fi. That is equal to 1860 divided by 30. That is equal to 62. So this method of finding mean of grouped data is called as direct method. Notice that we have found the mean for same data when it was ungrouped and when it was grouped. We have got two different answers. The reason behind this is that the class mark over here that represents this class interval is a mid value of that class interval. It is only a representative, not the exact data, and that is why this difference can be seen. Let's understand now the next method of finding mean. It is called as assumed mean method. I'm going to use the same example for which we found mean using direct method. Now sometimes we will find that the xi and fi are very large numbers. So finding the product fi into xi becomes tedious and time consuming. In such situations, we can use assumed mean method. The idea of this method is to make the numbers smaller. Now frequencies cannot be changed or reduced. So what we can do is we can change the class marks into a smaller number so that the calculations become easy. So the first step is to choose a number among the xi values as assumed mean. This number can be the middlemost number. Notice that there are 6 values of xi's over here. So you can choose 47.5 or you can choose 62.5. So let's choose 47.5 as the assumed mean number. So let A equal to 47.5. The next step is to find the difference D, which is given by x minus A. And we have to do this for each of the xi's. So we are going to write here di and xi. D is called as deviation. So for each of these class marks, we have to find deviation, by subtracting assumed mean from each of the xi's. So the first value of di is obtained by subtracting the assumed mean from 17.5. So it will be minus 30. Similarly, the next one is obtained by calculating 32.5 minus 47.5. So we get minus 15. And 47.5 minus 47.5 will be 0. For the next value, we calculate 62.5 minus 47.5. So for each of these class marks, we calculate deviation. Notice that di for the assumed mean value will be 0. And on one side of the di's, you will get negative values. On the other side, you will get positive values. And also notice that the difference between any two consecutive di values is same as the class size. The class size is given by upper limit minus lower limit. So in this case, the class size is 15. And the difference between the consecutive di's is also 15. The next step is to multiply each di with the corresponding fi and write it in the next column. After finding the product for each fi di, we have to add these numbers so that we get summation fi into di. And then we also have to find summation fi. So now if we find summation fi di divided by summation fi, we get the mean of deviations, which were obtained by subtracting a from each observation or xi values. Since we subtracted a over here, we will have to add a to this formula in order to get the mean of this given data. So the assumed mean formula will be a plus summation fi di divided by summation fi. So substituting a in this formula and summation fi di and summation fi, we get the mean of this data as 62, which is the same value that we had obtained when we used direct method. So whichever formula we use, direct method or assumed mean method, the answer is going to be same. Now let's apply these formula to solve some questions of exercise 14.1. This is question number 2. Consider the following distribution of daily wages of 50 workers of a factory. Find the mean of daily wages of workers of the factory by using an appropriate method. We will solve this question using both methods. To answer this question using direct method, we just need 4 columns. In the first column, we will write down daily wages, which are the class intervals. In the next column, we will show number of workers, which are the frequencies fi. In the third column, we will show the class mark, which is xi. And in the fourth column, we will find the product of fi and xi. The class marks are calculated by adding the lower limit and the upper limit and dividing by 2. So here we will get 110, in the next one 130, 150, 170 and 190. Now we will find the product of each xi and fi. Now we will find summation fi into xi, that is equal to 7260, and we will also find summation fi, which is equal to 50. It is already given in the question that there are 50 workers. So the total number of workers over here should be 50. Now we can apply the formula and find out mean summation Fi xi divided by summation Fi is equal to 7,260 divided by 50, and that is equal to 145.2 rupees. Don't forget to write the units. We are finding mean for this data, which is daily wages, and therefore the unit will be rupees. Notice that the xi are 3-digit numbers. They are very large numbers to multiply. So the appropriate method over here is the assumed mean method. I've used this method over here to show how big the numbers will become on finding the products. So let's apply the assumed mean method now. To use the assumed mean method, we need to draw a table with 5 columns. The first column will have class intervals. The second column will have corresponding frequencies. The third column will have class marks. In the fourth column, we are going to find out DI for each xi, which is given by xi minus a. And in the fifth column, we will write the product Fi into Di. So first we will have to choose an assumed mean from the list of xi's. The assumed mean should be the central value of all the xi's. Since there are 5 values, we can choose the middlemost value, which is 150. So we can say let the assumed mean be 150. Now we will find Di for each of the xi's. So 110 minus a, that is 110 minus 150 is minus 40. Then 130 minus 150 is minus 20. 150 minus 150 is 0. 170 minus 150 will give you 20, and similarly the last value will be 40. Now these xi values, which were 3-digit numbers, have reduced to 2-digit numbers. So now we can find the product of Fi and Di. So the first product will be minus 480. The second product will be minus 280. The third product will be 0. The fourth product will be 120. And the fifth product will be 400. Now we have to find summation Fi into Di. So we will add these numbers. Now be careful with the sign. Some numbers are negative and some numbers are positive. So the sum of these products Fi and Di's is minus 240. And summation Fi will be 50. Using the formula for assumed mean, x bar is equal to a plus summation Fi Di divided by summation Fi. So substituting the values, we get 150 plus minus 240 divided by 50. This is equal to 150 minus 4.8, which is equal to 145.20 rupees. So we get the same answer that we got when we used direct method. Question number 3. The following distribution shows the daily pocket allowance of children of a locality. So the first column is showing the class intervals or the groups into which this pocket allowance is divided. And the second column shows the frequency. That is the number of children getting these allowances. The mean pocket allowance is rupees 18. Find the missing frequency. So here we are given a different type of question where using the value of given mean, we have to find the missing frequency. So we will proceed in the same manner that we did earlier. We will use the assumed mean method. So the first column shows daily allowances in rupees, which are the class intervals. The second column shows number of children, that is the frequency. In the third column, we will write class marks, which will be lower limit plus upper limit divided by 2. So 11 plus 13 divided by 2 is 24 divided by 2, that is 12. Likewise, you can find all class marks. Now we have to assume a value for mean, which lies at the center of xi values. Since there are 7 xi values, we can choose the fourth one. So let 18 be the assumed mean. Now for each xi value, we have to find di, which is given by xi minus a. So 12 minus 18 gives us minus 6. 14 minus 18 gives us minus 4. The next will be minus 2, 0, 2, 4, 6. And then in the last column, we will find the product of fi di. So the first product is 7 into minus 6, which is minus 42. The next product is 6 into minus 4, that is minus 24, and so on. This product f into 2 will be written as 2f. Now we have to find the sum of these products. So minus 24 plus 24 will give us 0. Adding rest of the numbers, we get summation fi di equal to 2f minus 40. And summation fi is equal to 44 plus f. So these are the values that we have calculated, summation fi di, summation fi, and we have assumed the mean to be 18. So value of a is 18. And we are given in the question that the mean of this data, that is x bar, is 18. So now we can use the formula x bar is equal to a plus summation fi di divided by summation fi. So substituting, we get 18 equal to 18 plus 2f minus 40 divided by 44 plus f. Now when we take 18 to the left side, 18 minus 18 will become 0. So we have 2f minus 40 divided by 44 plus f equal to 0. So on cross multiplying, we get 2f minus 40 equal to 0. This implies 2f is equal to 40 or f is equal to 20. So the value of missing frequency is 20. With this, we come to the end of this video lesson. Your assignment for today are these two questions from exercise 14.1. Apply only one method in order to find the answer for each question. Now, which method you have to apply will be decided by looking at the values of xi and fi. If the values are very large, then you will opt for assumed mean method. If the values are small, then you can use direct method. See you in the next class. Until then, goodbye.